Hello guys, welcome back to my channel. As on African motifs, still working on the question paper for which was actually written in July 2019 for mathematics N3. So we shall have a continuation working on the second question now, where we are given it's actually 15 marks for that. As you can see, 15 marks. The first question that we worked on, it had 16 marks if you still remember the first part that we did together. So here we are given on question 2.1 that if log 2 is equal to a, write log 50 in terms of a. Okay, that was the question there. How can we actually write this, guys? We are given that log 2 is equivalent to a, and we want to write log 50 in terms of a. All right, so if we are to cross-check there, it's a condition that we are supposed to have, like to write in terms of some logarithms that we actually know, and also in terms of 2. In terms of 2, we are already given that in log 2 is equal to a. But there are these logarithms actually, if maybe we didn't talk about this, but you're supposed to know this from your N1, N2 mathematics. We talked about a condition where you are supposed to know the logarithm of 1 in base of 10, because if the base is not indicated, it means you're in base of 10. The logarithm of 1 is equivalent to 0. All right, the logarithm of 10 is equivalent to 1. The logarithm of 100 is equivalent to 2. So because you are in base 10, so these logarithms, you are supposed to know them. So it can be up to, what you just need to know is that the number of zeros here are the ones that you affect on your answer. We've got 1 0, we've got our 1, 2 zeros, 2, 3 zeros, so it's going to be 3. Here we do not have any 0 because it's just, so that is why our answer is a 0 there. So you're supposed to know these logarithms actually by head. So now, knowing these, how can they help us to find log 50? Because we are only given 2 and we can't obtain 50 from 2 like as factors of 2 there, of factors. The factors we can't do that. So the only thing that we can have is either to separate these numbers here that we have using 2 to give us this 50 here. So which numbers can we use? Actually, I'm going to focus on 102 because these two, they have got a great relationship. 50 isn't it the same as 100 like this divided by 2? It's just one and the same thing. Guys, what I'm trying to say is, if this question was saying we need to find log 8 in terms of a, we were not going to do all this because 8 can be found direct from 2, the one that we are given, because this is same as log 2 to the exponent of 3, which is 3 log 2. So, but this time it's impossible for us to express 2 from 50 like this. That is why you have to look for other numbers. But for this type of equation, it will be direct because you just substitute now in place of log 2, you substitute your a, so it's going to be 3a. But for log 50, it's different. So this one, what does it mean? Remember from your laws of logarithm, when you are dividing like this, it means you are going to subtract the logarithms. So this is going to be log 100 minus log 2. Log a over b, you subtract. All right, now you can substitute because the value of log 100 is there. Remember, the purpose of introducing this 100 is that we need a number that has a direct logarithm that we know, and we said log 100 is equal to 2. So in place of log 100, I'm going to substitute 2 minus log a. Log 2, our log 2 is equal to a. So in place of log 2, I'm going to substitute a. So this is going to be 2 minus a. So this is the value of log 50. So that was the concept, guys. So like I said, maybe the question wanted you to find log 8. You're going to say 2 to the exponent of 3 which is from your laws of logarithms. You drop this exponent, it will be 3 log 2, which is 3 times log 2. Log 2 is a, so 3 times a, which is 3a. So there can be different questions actually around that. You have to just play around the question and so forth. Maybe it was log 5, something like that. So log 5 is going to be what? It's going to be log 10 over 2. If you divide 10 divided by 2, you obtain 5, which is going to be log 10 minus log 2, of which we've got the value of log 10, because log 10 we said is 1. The number of zeros here is 1, so it's 1 minus log 2, which is a. We are given that log 2 is equal to a, so answer is going to be 1 minus a. So that's how you simplify these questions. Okay, so that was log 50. Let's see another question that we are actually given is to solve for x. Okay, so for x in each of the following. All right, so first one is 2.21, where we are given some exponents there. It's 2 to the exponent of 2x minus 1 minus 2 to the exponent of 2x, everything over 4 to the exponent of x. All right, then this one is the square root of 2 to the exponent of minus 3x, like this, minus 1. All right, so take note, guys, this is what you're actually given, and you've got 6 marks for that. Most cases, guys, try by all means to write the exponents in terms of the same number or the same base there. So you have to, like, what can we do, guys? Here we have got 2 to the exponent. It's 2, it's 2, it's 2. Here it's 4. So let's just try and write this in terms of what? In terms of 2, and see what we are going to have at the end. All right. So the first thing here is that on the top we can actually factor out, because remember 2 to the exponent of x, 2x minus 1, like this, is the same as 2 to the exponent of 2x times 2 to the exponent of negative 1. So which means this can be separated and you remain with 2 to the exponent of what? Of negative 1. So that means we can factor out 2 to the exponent of 2x, because it's common between these two. And here we are going to remain with 2 to the exponent of negative 1 minus, if I factor out 2 to the exponent of 2x here, from this one I'm going to remain with negative 1, like this. Everything over, remember we want to write in terms of 2, so this 4 in terms of 2 is same as 2 to the exponent of 2, like this, from this 4, but already there was an exponent of x, so it's going to be 2 to the exponent of 2x, like this. All right, which is equal to, here, yes, we've got the base of 2, but take a look, guys, take a look, there's a square root there. So what can we do? We know that from our laws of exponents, the square root of x is the same as x to the exponent of a half. So whenever you see a square root, you raise to the exponent of a half. So this one, we are going to raise it to the exponent of a half. So it will be 2 to the exponent of minus 3x, like this, to the exponent of a half. To remove this square root here, you raise to the exponent of a half. So that means these two can actually multiply. Minus 3 times a half is minus 3 over 2x. All right, from your calculator, minus 3 times 1 over 2 gives you minus 3 over 2. So it's going to be 2 to the exponent of minus 3 over 2x. All right, minus 1. So this will be minus 1, this one. We just leave it like that, because here we also have a negative 1. So maybe just leave it like that. All right, then what do we have here? Actually, there's something that happened here. These two are the same, so they can actually cancel out, because this is multiplying. So these two have got the power to cancel each other. Now simplify this from your calculator. 2 to the exponent of negative 1 minus 1. This one from your calculator is going to give you a minus half, like this. which is equal to 2 to the exponent of minus 3 over 2x minus 1, like this. All right, still, what can we do now? All right, let's collect terms, because these two terms here, they do not have x, so you can actually collect them to one side of the equation. Transpose this is going to be a positive one, so it will be 1 minus a half, which is a half. So this is going to give us 1 over 2 equal to 2 to the exponent of minus 3 over 2x. Still moving, this is 1 over 2. This is 2 to the exponent. So from our laws of exponents, remember 1 over x is the same as x to the exponent of negative 1. So 1 over 2 is the same as 2 to the exponent of negative 1, like this. 2 to the exponent of negative 1 from this one, which is equal to this. Why are we even doing this? Because we know that once this condition occurs of having the bases which are the same equated together like this, it means the exponents are automatically the same. The exponents are automatically the same. Minus 1 will be equal to minus 3 over 2x, like that, without any exponent. So you can actually solve for x there. How do I solve for x? That's the question. So many ways. I can just divide by minus 3 over 2 both sides, by minus 3 over 2 both sides. So this can cancel. So therefore my x is going to be 2 over 3. If I divide properly from my calculator, I'm going to obtain 2 over 3 there. So as we can see, guys, that the question that you be given, actually the ones that you be given to solve, you have to be very, very careful with the working that you're applying there, the stages and exponents, the laws of exponents. So as you can see, actually Maths N3, it requires you to know the applications of your laws of exponents. It's not just about answering the question. Know your laws of exponents, know your laws of logarithms. All those, you must know them. It's a stage in engineering where they want you to understand what you are actually talking about in maths, because any moment from there is now application. So actually N3, they need you to know what you're doing there. So please let us revise while there is time. All right, anyways, on 2.22 we are now asked to solve again for x, but this time it's a log, and we've got 7 marks for that. So which means we have got something again there which they are testing us to give there. So this is log x base 2 minus 3 log 2 base x. Take note there, the bases, they are not the same. That is why it has to go to 7 marks like that. As we can see, these bases are not the same, and 7 marks for that to make it 15. Okay, what can we do there? The first thing is, we know from our laws of logarithms that actually when the bases are not the same, there's an interchanging of bases which can occur provided that you apply it properly. Log a base b like this is the same as writing as 1 over log b base a. Take note here, there is going to be something that is going to change here. The moment we introduce 1 over like that, this is going to interchange. As you can see, it's now on the base. This is now the nub. So that is the concept. These two, they are the same. These two. So you haven't changed anything by writing like this. So you can choose to change, because these bases are not the same. So you can choose to change 1, not 2 of them. Only 1. All right, so in this case, I'm going to choose to change this one. Second one, this one. This one I'm going to just remain as it's going to remain as it is. So it will be log x base 2 like this. What I want to change, guys, take note, is this part here, this one. This is the one that I want to change here. So it's the one which is going to be written as 1 over. So it's going to be minus 3 like this. Then it's 1 over like this. The moment you write it as 1 over, these two, they interchange, just like what we did here. They interchange. So it's going to be x base 2 like this. These ones will interchange like that, which is equal to 2. So that is the secret, or that is the as you can see now, these are having the same properties, log x base 2, log x base 2, but you interchange these two, they are the same. You don't interchange this one also, because once you do here, it will do another way, so that one will be wrong. Now this is what I'm going to have. I have this one is now a fraction, so I have to remove this fraction. So definitely from your fractions, you know that to remove this, you have to multiply by the denominator, of which this is your denominator here. So you multiply each and every term by log x base 2, which is your denominator here. You multiply also here by log x base 2, which is your denominator here, also by log x base 2, which is your denominator also. So as we are doing this, as we can see here, it's log x base 2 times log x base 2. These two are actually the same, just like 3 times 3. If you're multiplying 3 times 3 and you write it as 3 squared, are you wrong? No, it's just one and the same thing. So it means these two can be written just one and the same thing as log x base 2 in a bracket like this, squared. Just one and the same thing. Minus, this will cancel, just like you're multiplying 1 over 2 times 2. This can cancel. So it's the same thing. Log x base 2, log x base 2 can cancel. Therefore, you are remaining with minus 3. So it will be minus 3 like this, equal to 2 times log x base 2. So this one will be just like 2 log x base 2. Nothing much, just write as it is. All right. Now I have to solve. How am I going to solve this, guys? Just as you can see, there's now a highest exponent of 2. So it's now having a format of a quadratic equation where I have to leave one side to be equal to 0. So this will be log x base 2 squared like this. I take this to the other side of the equation. It's going to be minus 2 log x base 2 like this. All right, already I had minus 3, so it's going to be minus 3 like this is equal to 0. All right, so this is what I'm going to have. But now the question is, how are we going to solve this type of an equation? Yes, these two are the same, log x base 2, log x base 2, something like that. All right, so this is the consideration. You can actually choose to work this as it is in log form, factorize in a log form, but it's going to be a risky question if you do not understand the basic concept of factorization. This is going to be a risky type of a working. So how do I avoid that risky type of a working? I'm going to introduce a certain letter that represents log x base 2. So I'm just going to introduce something like this. Let's just say let k be equal to, I'm introducing the letter k in place of log x base 2. So let it be equal to log x base 2 like this. So the moment I say let k be equal to, it means in place of log x base 2, I'm now having a k there. But take note, it's raised to the exponent of 2. Minus 2 in place of log x base 2, I'm going to replace with a k, so it's going to be minus 2k. Minus 3, there is no log here, so it's just going to be minus 3 like this. So as you can see, it's the same equation, but now in terms of k, because we have introduced something in place of k. So this is now an easier equation for us to solve, because we actually know that if we have got k squared minus 2k minus 3 is equal to 0 like this, we just say equivalent of k squared is 1. So we are going to have 2 brackets, of which we're supposed to do this using logarithms. But it's a risk. That's why I'm saying avoid that. So this is going to be k here, and we've got minus 3. What are the factors of minus 3? Which gives us negative 2. So that's minus 3 and 1. Minus 3 times 1 is minus 3. Minus 3 plus 1 is minus 2. So you've got minus 3 minus 1, plus 1, sorry. Minus 3 here plus 1 is equal to 0. So k is equal to 3. Remember, each bracket is equal to 0. So k is equal to 3, or k is equivalent to negative 1. Alright. This is it. What have you just found is not what you were asked to calculate. The question is asking you to solve for x. That was the equation. We introduced the k here to help us solve the logarithms. So therefore, we must go back to that part where we said let k be equal to. So that means in place of k, I'm going to have this now as log x base 2. Remember, is equal to, we said let it be equal to k. So log x base 2 is equal to k, and our k is 3. So we are going to equate to 3. Alright. Or we move on to another one, log x base 2, which is this one is equal to k, and our k is a negative 1, like this. So we have formulated the one equation that we are supposed to solve, the one that we needed in terms of x. So how am I going to find the value of x? Remember, guys, from your laws of logarithms, log a base b is equal to c can be written in exponent form as a is equal to b to the exponent of c. ABC, ABC. A here is now your a here. So this is what we have. This is your a, which is your x here. So therefore, our x is going to be 2 to the exponent of 3, just like this. B to the exponent of c. So it's 2 to the exponent of 3, which is going to give us 8. So that's the first value of x. Or we move on to this one, x, just like this part. Our x here is going to be 2 to the exponent of negative 1, which is the same as 1 over 2. Same as 1 over 2. So these are the values of x. X can be 8 or x can be 1 over 2. But we have to now cross-check which one is the right one and so forth. So you can do that and see if we are going to have anything, but that is the working that we can actually involve there. So I don't know which working is best for you, or depends with how you actually simplify or how you actually work out your questions. And that is what is important for this stage, to know the method that you're going to actually apply. Which method are you going to apply, and also to revise along each and every method. If there's a method that you say this is the right method for me, then apply that method to the maximum, revise as much. But this can be the easiest method, as we can see. So we shall meet again, guys, on our next episode, working on the other questions, as we shall be preparing, guys, for the exams which are actually ahead of time. So remember, guys, the exams, they are ahead of time, so let's give it in our time to revise, as we know that very soon, according to your timetables and so forth. So we shall meet again in another class from Mason African Motives. Till we meet again.